Let's do some more examples of solving radical equations. So solving radical equations, remember we follow the steps that we've learned about isolating the radical, solving by usually squaring both sides or cubing both sides, solving the resulting one, and then checking your answer if the original index is even. So I'm going to add 5 to both sides to solve this one. So I get the square root of 2x plus 4 is equal to 6. Square both sides to get rid of that square root. So that's the inverse operation is to square to get rid of a square root. So I get a 36. Then I subtract 4. I get 32. So x equals 16. Okay, let's check out to see if we get that as a check, because my index is even. So check it. And so you want to show here that 16 times 2 is 32, plus 4 is minus 5. Does that equal 1? This is square root of 36, which is just 6 minus 5 does equal 1, so it checks. So my answer is just 16 for this one. Let's try the next one. Again, the square roots now are by themselves already. I can square both sides, and that's going to get rid of both of those square roots, which is very fortunate. So if I get rid of that, I get x minus 5 equal to 3x minus 21. So notice when here I had to square a number, that changed it, but here with both square roots on both sides, when I square both sides, that will get rid of the square roots. Now I go ahead and solve this, so I'm going to subtract x from both sides. So I'm going to get 2x here. I'm going to add 21 to both sides, so you get 2x equal to, that would be 16. Divide by 2, and you get x equal to 8. Even index, you got to check your answer. So if I check it, I'm going to go ahead and put in 8 there, so 8 minus 5. Square root of 8 minus 5 here. Does that equal the square root of, put 8 in here, you get 24 minus 21. So the square root of 3, does that equal the square root of 3? And the answer is yes, it does. It's not a nice number to get the square root of, but we get it checked off because they're both the same. So my answer then is 8 for this one. All right, let's try the next one. It's an odd index, so I'm not going to have to necessarily check. I'm going to do it just for good form to see if I did my work right. Let's subtract 8 from both sides. So the cube root of x is equal to negative 6 in this case. Now, I can cube a negative, and it gets me a negative. If you cube negative 6, you get negative 216. If you cube this side, it just gets rid of the cube root. Make sure when you cube this here, you recognize that you can get a negative. So if I check my answer here, and I get, on this I get 8 plus the cube root of negative 216. Does that equal 2? And 8 plus, this is a negative 8. Does that, this is a negative 6. When I cube root the negative 216. Does that equal 2? And the answer is yes. So my answer is negative 216. All right, so let's do number 4 here. Squaring both sides. I'm gonna, because it's a square root, I'm gonna make sure I check my answer. So x squared equals 2x plus 15. This is a quadratic. To solve a quadratic, you get 0 on one side. So x squared minus 2x minus 15 equals 0. So you subtract 2x from both sides, subtract 15 to get 0 here. Now I'm going to factor to solve this one. You could use the quadratic formula as well. So x and x, two numbers that multiply to get negative 15, add to get negative 2. That's going to be a negative 5 and a positive 3. Let's check these. X minus 5 equals 0. X equals 5, x plus 3 equals 0, x equals negative 3. So let's check them. I'm going to check them over here. X equals 5 first. Does 5 equal the square root of 10 plus 15? Which does 5 equal equals square root of 25? And the answer is yes, it does. So that checks, so 5 is an answer. Let's check negative 3. So does negative 3 equal the square root of negative 6 plus 15? So does negative 3 equal the square root of 9? The answer is no, it does not, because square root of 9 is positive 3. So we created, that's called an extraneous solution. Extraneous because it is a solution created by this squaring step when I square both sides, but it's not an actual solution to the equation. So my only answer is this 5. So we disallow the negative 3. And lastly, let's do this one. This one is a little more complicated. This is a more advanced problem. And the reason why it's advanced is because you got 2 square roots on both sides, and when I square, you're going to have to repeat the steps for this. So when I square this side, I get x minus 12 equals, and squaring this side, I'm going to have to do 2 minus the square root of x times 2 minus the square root of x. So let's see what that gives us. That's 4 minus 2 square roots of x minus 2 square roots of x when I do these two, and then minus square root of x. So I'm going to do these last two here. Negative square root of x times negative square root of x is a positive. Square root of x times square root of x. If you multiply 2 square roots that are the same radicand together, you get just the radicand, and so it's just going to be plus an x. Again, if you want to think of it this way, it's the square root of x squared. Square root of x squared is just x. Now I'm going to go ahead and combine terms. So I'm going to have x, if I subtract x on both sides, notice there's no more x's. So negative 12 equals 4 minus 4 square roots of x. Negative 2 square roots of x minus 2 square roots of x is negative 4 square roots of x. Subtract 4, you get negative 16 is equal to negative 4 square roots of x. Divide by negative 4, you get square root of x is equal to a positive 4. Square both sides and you get x is equal to 16. Now let's check that out to see if it works. Okay, so if I check this, okay, sometimes it will work and sometimes it doesn't. Let's check it out in the original. Square root of 16 minus 12, does that equal 2 minus the square root of 16? Does the square root of 4 equal 2 minus 4? And the answer is no, it doesn't, because that's a negative, this is a positive. So we've created one that we thought the answer was 16, but it's an extraneous solution. There is no solution to this one. And when you come up with an answer like that where the answer does not check, you have no solution. So these are just more examples of solving radical equations. Make sure you follow the steps that we've come up with, and then when it's an even index, make sure you check your answers.